Alright guys, so we are starting a new unit today over factoring. We are going to start our factoring with greatest common factor, or GCF. So we first want to touch base on what a factor is. So factors are numbers that we can multiply together to get another number. A number can have many factors, like you'll see in some of our examples, or it could just have a couple of factors. So for example, the number 3. Its factors are only 1 and 3, because 1 and 3 are the only two numbers that we can multiply together to get the number 3. Alright, so now that we know what a factor is, let's talk about a common factor. So in order to find a common factor, we need to find the factors of two numbers or more than two numbers. Individually, we need to find those factors of each. So let's look at 12. So for 12, we've got 1 times 12. Those are both factors of 12. 2 times 6 would give me 12. And then 3 times 4 would also give me 12. So these are all my factors of 12. Now I'm going to do this for 30. So 1 times 30 will obviously give me 30. 2 times 15 will give me 30. 3 times 10 will give me 30, and then I'm going to squeeze 5 times 6 right there in the middle. Alright, so these are my factors of 12, and these are all my factors of 30. So we're talking about the common factor. So the common factor are those that are found on both lists. So if you can see, we've got 1 is on both lists. 2 is on both lists, 3 is on both lists, 4 is only on the 12. So 4 is only a factor of 12, so it would not be a common factor. Then we've got 6, and then 12 is not on both, so that's not a common factor either. So we just had 4 common factors. So now let's look at the greatest common factor. So greatest common factor is just simply what it sounds like. It is the largest of our common factors. So if these are our common factors, then that greatest common factor is this biggest number right here, which is 6. Easy enough, guys. Okay, so let's look at our first example. We're going to factor out the greatest common factor in our polynomial. So we want to look at 3 and what its factors are. Well, we know that 1 times 3, and that's it. So then let's look at 12. So 12 we already did over on the first page example. So we've got 1, 2, 3, 4, 6, and 12. Alright, so our greatest common factor between these two is going to be the biggest number that they share in common. So 3 is our GCF. So our GCF is 3. So when I factor this polynomial, and I'm going to rewrite it right here, I'm going to write my GCF first, which is 3. And I forgot to. Alright, so it's a 3, and then I'm going to open a set of parentheses, and I'm going to ask myself, what do I need to multiply this 3 by in order to get to 3x? Well, 3 times x would give me a 3x, so the first term inside my parentheses is an x. Now I want to ask myself again, what do I multiply this 3 by in order to get to a positive 12? Well, I would need to multiply 3 by positive 4. So there is my answer. I have factored the greatest common factor out of my original polynomial. These two things are equal. If you're ever worried, if maybe you've done something wrong, you can always distribute this 3 in and multiply it out and see if your answer ends up being the same as what you started with. And if it is, then you've done it correctly. All right, let's go down to the next example. So we've got our numbers out in front, just like we had in our example 1, but we've got variables this time on both of our terms. So let's start by finding our factors of 5. So just 1 times 5 are the factors of 5, and then we need to find the factors of 10. Well, that's 1 times 10 and 2 times 5. So our greatest common factor here between our coefficients, which this number out in front of the variable is our coefficient, our greatest common factor is the 5. So I'm going to write over here that my greatest common factor is 5. But I still have to deal with those little variables. So I'm going to write those off to the side over here. So I have y squared and a y. So what do I multiply together to get y squared? Well, it's just simply y times y. And for y, that's just simply y. All right, so we need to look at the variables and figure out how many they share in common. Well, they share one y in common. So our GCF includes that one y. And this will make more sense as we end up with larger and larger degrees on our variables. All right, so let's go ahead and rewrite the original polynomial. So we've got 5y squared plus 10y, and that equals, well, we're going to first write our GCF. So that is 5y, open a parentheses, and we need to ask ourselves, what do we multiply this 5y by in order to get to 5y squared? Well, we would just multiply it by a y. So the first term inside of our parentheses is just a y. Now we need, I kind of got ahead of myself, didn't I? Sorry. All right, so now we're going to ask ourselves the same thing. What am I multiplying 5y by in order to get to 10y? Well, all I would need to do is multiply it by 2, because 2 times 5 would give us a 10y. So 2. So this is our factored polynomial. We have factored out our GCF. All right, let's go to example 3. So we've got 3 terms now, so we're going to have to go ahead and do factors for 20. So that is 1 times 20, 2 times 10. I think I'm going to run out of room here. And 4 times 5. All right, the next one is 10, which is, we did in the example above, so we know that's just 1, 2, 5, and 10. And then lastly is 15. So we've got 1 and 15, and then 3 and 5. Oops, sorry. Okay, so we want to figure out what our GCF is. So we've got to figure out which numbers they have in common and which is the largest of those common factors. So I see that 20 and 10 both share a 10 in common, but the 15 doesn't share that in common, so that can't be our GCF. But if we go down one number, we've got a 5, and a 5 that they all share in common. So we're going to start off with our GCF for our coefficients, factoring out a 5. Now we've got to look at those little variables. So we're going to start off with x to the 5th. That is 5 x's. So 1, 2, 3, 4, and 5. And as you get better at this, you won't have to write these out all the way like this. So x to the 4th is 1, 2, 3, 4 x's, and x cubed is 1, 2, and 3 x's. So we want to look at these and figure out how many x's they share in common. Well, I've got 3 x's here, 3 x's there, and 3 x's there. So that tells me that I can factor out a GCF on these variables of x to the 3rd because they all share that in common. All right, so now I'm going to, I'm not going to rewrite it this time because I'm kind of running out of space here. So I'm going to start by writing my GCF. So I've got 5x cubed, open my parentheses, and now I ask myself, what do I multiply this 5x cubed by to get up to 20x to the 5th? So 5 times what would give me 20? Well, 5 times 4 would give me a 20. And how many x's did I leave behind? I left behind 2. So if I multiply 5x cubed times 4x squared, it's going to give me 20x to the 5th. All right, now I'm going to do my next term. So I need to figure out what I multiply 5x cubed by in order to get 10x to the 4th. So 5 times 2, positive 2, will get me that 10, and I left 1x that I didn't circle. And then lastly, I've got this last term, negative 15x cubed. So what do I multiply this 5x cubed by to get to negative 15x cubed? Just simply a negative 3. I had no x's left over, so there's no x on that term. And that is how we would factor out a trinomial. All right, last example. We're almost done. Okay, let's look here. What are our greatest factors of the 3 terms right here? So let's go ahead and do these over here. We've got an 8, a 16, and a 4. All right, so I've got 1, 8, 2, and 4. And then for 16, I've got a 1, a 16, a 2, and an 8, and a 4, and a 4, which kind of don't really need to write it again. 4 and 4. It's obvious. All right, and then for 4, I've got 1, and 4, and 2. Okay. So let's figure out what our GCF is. We can see right off the bat that our GCF for our coefficients is 4. And then we've got to deal with those variables. So this is 4 x's, this is 3 x's, and this is 2 x's. So they're all going to share in common or have at least an x squared in them. So let's go ahead and add that to the GCF. One other thing is that if this leading term right here is negative, we try not to have that leading term be negative. So what I want to do is factor a negative out with everything else that we're doing. So if this leading term is negative, let's just go ahead and factor a negative out. So this GCF is going to be a negative 4x squared. So now let's talk about how that affects everything else as we factor that GCF out. So I've written my GCF, I'm going to open my parentheses, I'm going to ask myself the same question again. What am I multiplying that GCF by in order to get to this first term? So what would I multiply negative 4 by to get to negative 8? Well, that's simple. I would just multiply it by a positive 2. I would multiply x squared by what to get to x to the 4th? Well, just an x squared. Now I do the same thing for my next term. What do I multiply this by to get to positive 16x cubed? Well, I would need to multiply negative 4 by a negative 4, because negative 4 times negative 4 would give us that positive 16 that we're looking for. Then we've got x squared. I need x cubed, so I need one more x. And then the last term on the end. So what do I multiply this by in order to get to negative 4x squared? Well, I would want to multiply it by a positive 1. Then it stays exactly the same. And I close my parentheses, and I am done. So you can see that when we factored out that negative in our GCF, it changes the sign or the negative or positive on each of our terms. So our first term was negative, and our final answer it's positive. This one was positive, now it's negative, and this one was a negative, and now it's a positive. All right, guys, well, hopefully this helps, and you can get all your answers on your homework correct. Thanks.